10 mind-blowing facts you didn't know about the moon. If you're into science, you've probably heard that the moon doesn't rotate, and that's why we always see the same side, which causes the moon to have a dark side that we never see. But did you know that the moon actually does rotate and this supposed dark side is not either? That's right. In this video, we'll debunk myths about the moon and more. Let's get started. The South Pole-Aitken crater is one of the oldest craters in the solar system. In the southern region of the far side of the moon is one of the most colossal and oldest structures in the solar system, the South Pole-Aitken SPA crater. With a diameter of approximately 2,500 kilometers and a depth of 8 to 13 kilometers, this gigantic impact basin is not only the largest on the moon, but also one of the oldest in the entire solar system. It is estimated that the impact that formed this basin occurred more than 4 billion years ago, during the so-called Late Intense Bombardment, a time when numerous asteroids collided with the internal bodies of the solar system. The energy released was so enormous that it penetrated the surface layers of the lunar mantle, revealing deep materials that are now the object of scientific study. This crater is of special interest because, unlike other lunar basins, it has not been covered by basaltic lava, allowing its original structure to remain more exposed. The Lunar Reconnaissance Orbiter and Chang'e 4 missions have collected data on this region, revealing unusual chemical compositions and signs of minerals such as olivine, which are associated with the lunar mantle. The SPA provides a natural window into the moon's interior and its early evolution. If a future mission could bring back samples directly from its surface, we would gain key information about the formation of rocky bodies, the history of giant impacts, and potentially about the processes that gave rise to Earth itself. Attempts have been made on Earth to replicate lunar regolith, but all have failed. Lunar regolith, that layer of dust and rock fragments that covers the entire surface of the moon, is critical to any exploration, construction, or mining mission outside of Earth. However, faithfully replicating it on Earth has been an enormous challenge for science. Despite decades of effort, there is no perfect stimulant that reproduces all its physical, chemical, and mechanical characteristics. Lunar regolith is the result of billions of years of meteoritic impacts, without the intervention of atmosphere, water, or biological processes. This gives it a wonderful but abrasive texture, with angular, electrostatically active particles, which are not found naturally on our planet. In addition, its composition varies according to the lunar region, with regoliths rich in basalt, anorthosite, and even containing the presence of helium-3 and rare metals. For training, machinery design, and experimentation purposes, NASA and other agencies have developed artificial stimulants such as JSC-1, NU-LHT, or LMS-1 using crushed terrestrial volcanic materials. While these materials enable the development of rovers, tools, and filtering systems, they cannot fully replicate the crystal structure, electrostatic charge, or interaction with ultraviolet and cosmic radiation that real regolith experiences on the moon. This limitation represents a critical challenge for lunar-based planning, as the behavior of regolith can affect everything from vehicle mobility to the integrity of structures and spacesuits. Understanding and stimulating it correctly is not just a matter of engineering, but a necessary step towards human permanence outside the Earth. The moon rotates on its axis in 27.3 days, the same time it takes to orbit the Earth. One of the most curious characteristics of the moon is that it always shows the same face towards the Earth. This phenomenon, known as synchronous rotation, occurs because the time it takes for the moon to complete a rotation on its axis, 27.3 days, is the same as it takes to orbit the Earth once. As a result, from our planet, we always observe the same lunar hemisphere, while the other remains hidden, except for the slight variations caused by libration. This synchrony is not a coincidence, but the result of a natural process called tidal coupling. Billions of years ago, the moon rotated faster, but the Earth's gravitational forces exerted a progressive brake on its rotation. Over time, this interaction dissipated internal energy and brought the Earth-Moon system into a stable state, in which both bodies are partially tidally locked. This balance has important implications. For example, it affects the thermal distribution on the lunar surface. The visible and hidden hemispheres have hidden geological histories, different exposure to solar bombardment, and therefore slightly different surface compositions. In addition, it has influenced how we have studied the Moon historically. Until 1959, when the Soviet probe Luna 3 first photographed the far side, humanity had no idea what was on the other side. Synchronous rotation is also observed on other satellites in the solar system, such as the moons of Jupiter and Saturn, showing that it is a common phenomenon in orbital dynamics. Understanding this type of coupling helps us model planetary systems, study the stability of exoplanets, and explain why the Moon, although it rotates, appears to be eternally motionless. Chang'e 4 was the first mission to land on the far side. On January 3, 2019, the Chang'e 4 mission of the Chinese Space Agency, the CNSA, achieved a historic milestone, becoming the first probe to land on the far side of the Moon, a region until then unexplored by robotic or manned missions. The landing site was the von Karman crater, located within the gigantic South Pole-Aitken basin, on the side we never see from Earth. The feat was not only technically challenging, but also strategically significant. The far side of the Moon never has a direct line of communication with Earth, which forced the CNSA to previously launch a repeater satellite called Queqiao, placed at a gravitational equilibrium point, the L2 point of the Earth-Moon system, from where it can transmit signals between Chang'e 4 and the Earth's control centers. The mission carried with it a lander and a rover called U-22, which has far exceeded its expected lifespan. U-22 has been exploring the terrain, analyzing the composition of the regolith, measuring surface radiation, and detecting signs of possible lunar mantle materials. In addition, Chang'e 4 included a small biological experiment that transported cotton seeds, potatoes, and fruit fly eggs, all inside a sealed mini greenhouse. Surprisingly, one of the cotton seeds did germinate, marking the first time a vegetable sprout has occurred on the lunar surface. However, it did not survive the extreme thermal cycle of the lunar night. Beyond its geopolitical symbolism, Chang'e 4 represents a significant scientific achievement. It has opened a new frontier for lunar exploration, demonstrating that it is possible to operate sustainably in the most mysterious and least understood region of our natural satellite. Hello. Before continuing, like this video if you're enjoying it, and don't forget to subscribe to our channel by activating the notification bell so you don't miss any of our daily videos. It is possible to use lunar regolith to print habitats with 3D robots. One of the most promising lines of research for lunar colonization is the possibility of building habitats directly with local materials, without the need to transport tons of structures from Earth. This approach, known as in situ resource utilization or ISRU, identifies lunar regolith, the dust and fragments that cover the entire surface, as an ideal candidate for 3D printing shelters. Lunar regolith is abundant, covering the entire surface, and has properties that can be exploited to generate solid and resilient structures. Using microwave fusion or laser sintering techniques, scientists have demonstrated in the laboratory that it is possible to compact simulated regolith to form solid blocks or interconnected layers. These blocks could serve as protective walls against radiation, micrometeorite impact, and the extreme temperatures that characterize the Moon. Several projects in Europe, the United States, and China are developing autonomous or semi-autonomous robots capable of printing three-dimensional structures layer by layer, using only regolith and solar energy. ESA, for example, has collaborated with the firm Foster Plus Partners on modular designs for 3D printed lunar dwellings, featuring inflatable domes with a layer of molten regolith. This type of technology would not only enable the establishment of sustainable lunar bases, but would also drastically reduce the cost of future manned missions. Instead of sending materials from Earth, it would be enough to send the robots and equipment needed for them to build using what is already available. Although we are still in experimental phases, the advances in 3D printing with local resources do not only apply to the Moon. It's a technology with an eye toward Mars and beyond, transforming space exploration into something much more accessible and viable in the long term. The Moon could contain navigable underground lava tunnels. Beneath the Moon's silent surface could be hidden natural structures that are as surprising as they are helpful. Underground lava tunnels, also known as lava tubes. These formations, well known on Earth, such as in Hawaii or Iceland, originate when lava flows through a channel and the outer part solidifies while the interior continues to move. When the flow stops, an empty tunnel-like duct remains. On the Moon, where there is no erosion or active tectonics, these tunnels could have been preserved almost intact for billions of years. The first clues to their existence come from orbital images obtained by missions such as the Lunar Reconnaissance Orbiter, the LRO, which detected collapse pits, circular openings with abrupt edges, which could be entrances to underground tunnels. Models based on lunar activity and radar simulations suggest that some of these tubes could reach tens of meters in width and extend for kilometers, enough to house vehicles, laboratories, or even future human bases. The scientific and strategic interest is clear. These tunnels offer natural protection against cosmic radiation, micrometeorite impacts, and extreme temperature swings on the lunar surface. In addition, they could preserve valuable geological records, and if there is ice trapped inside, even be a source of resources. Exploring them remains a challenge. A robotic mission specifically designed to descend into one of these wells has not yet been sent. However, there are already proposals from ESA, JAXA, NASA, and others to develop specialized exploration robots capable of mapping and studying the interiors of these cavities. If confirmed to exist, the lava tubes could become the first habitable natural shelters outside Earth, a crucial step towards a permanent human presence on the Moon. The Moon stabilizes the Earth's axis of rotation. The Moon not only beautifies our nights, it also plays a critical role in the climate stability of our planet. One of its most important and often ignored effects is that it stabilizes the Earth's axis of rotation, which keeps the planet's axial tilt relatively constant over time. Currently, the Earth's axis is tilted about 23.5 degrees concerning the plane of its orbit, and this inclination is directly responsible for the existence of the seasons of the year. However, this angle could vary much more if it were not for the gravitational influence of the Moon. Studies of planetary dynamics suggest that without our natural satellite, the Earth's axis tilt could chaotically oscillate between 0 and 85 degrees on a million-year scale. These kinds of extreme variations would produce radical climate changes, with unpredictable seasons, torrid summers at the poles, perpetual winters at the equator, and a much more unstable atmosphere. Under these conditions, complex life, and especially human civilization, would have severe difficulties in developing or sustaining itself. The Moon acts as a gravitational counterweight. Its mass, although much smaller than that of the Earth, is enough to slow down these oscillations, generating a kind of gyroscopic effect that dampers the movements of the axis. This phenomenon has been confirmed by astronomical models and computer simulations. It is one of the strongest arguments used to explain why the Earth has maintained a moderately stable climate for hundreds of millions of years. Some scientists speculate that the presence of a large, nearby moon similar to our own would be a key factor when searching for habitable planets in other solar systems. It is not enough to be in the habitable zone. Long-term stability also matters. In that sense, the Moon might not just be our satellite, but also the silent guarantor of life as we know it. The moon features unexplained magnetic swirls. Although the moon lacks a global magnetic field like Earth's, its surface presents a puzzling phenomena: localized regions with strong magnetism known as lunar magnetic eddies. These areas, scattered across various locations on the satellite, have defied scientists for decades with their unknown origin and unusual properties. One of the most prominent examples is Reiner Gamma, a bright whirlpool located on the near side of the moon. Its spiral shape and high reflectivity contrast sharply with the surrounding terrain. In addition, the probes have detected intense local magnetic fields in this region, which is unexpected in a body without a liquid core or active internal dynamo. The most curious thing is that these eddies are not associated with impact craters or obvious surface geological features. Some scientists believe they could be remnants of ancient magnetic fields generated when the moon still had a partially liquid core. Others propose that they are the result of impacts of comets rich in ferromagnetic materials, which would have locally altered the magnetization of the regolith. Another hypothesis suggests that local magnetic fields protect certain areas from erosion caused by the solar wind, which would explain their superior brightness. These magnetized areas would act as shields, preventing solar particles from obscuring the ground, as happens on the rest of the lunar surface. Although the Apollo missions measured magnetic anomalies on the moon, it was not until modern orbiters such as Lunar Prospector and Kaguya mapped these fields more accurately. However, the exact origin of magnetic eddies remains a mystery, and understanding them could provide key insights into the moon's geological and magnetic past. In addition to their scientific interest, these fields could have practical implications. If understood and controlled, they could be utilized in future missions to protect equipment or even lunar habitats from solar radiation, leveraging the natural magnetism of the terrain itself. No one can claim ownership over the moon legally. Although it may seem like something out of a science fiction novel, even in the 1960s and 1970s, governments around the world began to worry about the possibility that some country, company, or individual would attempt to take over the moon or other celestial bodies. To avoid a territorial race in outer space, an international legal framework was established, the Outer Space Treaty, signed in 1967 and ratified to this day by more than 110 countries, including all major space powers. This treaty establishes that no nation can claim sovereignty over the moon, nor place military bases, nor install weapons of mass destruction on its surface or in orbit. The moon, as well as other celestial bodies, is considered part of the common heritage of humanity, a space intended exclusively for peaceful, scientific purposes and collective benefit. In addition, the treaty prohibits appropriation by occupation or use, which also limits direct commercial aspirations on lunar soil. However, the issue is more complex when it comes to extracted resources. Although you cannot own the moon, some countries such as the United States and Luxembourg have passed laws that allow companies to claim the resources they extract, including water, regolith, and helium-3. This has generated legal and ethical debates that are ongoing and evolving. There are also complementary treaties, such as the 1979 Moon Agreement, which sought to regulate the use of lunar resources more strictly. However, most space powers rejected it, and today it has few signatories, so it has no effective force. In practice, this means that it is not legal to sell plots on the moon, even if certain companies do so as a symbolic gift. It also implies that if a lunar base is established in the future, its presence will not grant property rights over the land it occupies. Space law is still an evolving field, and as lunar exploration progresses, it will become increasingly urgent to establish transparent, fair, and sustainable rules to prevent conflicts beyond our planet. The largest radio telescope in the solar system is planned to be built in a lunar crater. In one of the most ambitious proposals in modern astronomy, NASA scientists have proposed constructing the largest radio telescope in the solar system on the far side of the Moon, not on Earth. The project, known as the Lunar Crater Radio Telescope, the LCRT, involves deploying a gigantic antenna more than 1 kilometer in diameter within a natural crater, utilizing autonomous robots. The far side of the Moon offers an unprecedented advantage for astronomical observation. It is permanently protected from terrestrial radio noise. This includes interference from telecommunications, radar, satellites, and all the technological noise that affects current radio telescopes. In addition, since the Moon has no atmosphere or ionosphere, it allows us to observe extremely long wavelengths that are absorbed or reflected by the Earth's atmosphere. The Lunar Radio Telescope would be composed of an ultra-light metal mesh deployed over the natural cavity of the crater by small climbing robots. The team behind it estimates that it could be built without the need for human presence, using prefabricated materials and solar energy. The LCRT would enable the study of the early universe at frequencies below 30 MHz, a band that has never been thoroughly explored. It is hoped that it will be able to detect signals coming from the so-called dark ages of the universe, a stage that occurred after the Big Bang and before the first stars formed, of which we have no direct observations. In addition, a lunar radio telescope would be ideal for searching for technological signatures, technomarkers, of advanced civilizations in other galaxies, by operating in silent bands where artificial communications could be emitted. Although still in the conceptual phase, the LCRT represents the kind of visionary ideas that could revolutionize our understanding of the cosmos. If it materializes, it would transform the far side of the Moon into the quietest, most profound, and most powerful observatory in the nearby universe. Today, we know we can use lunar regolith to build habitats. We have more technology and better spacecraft than astronauts had 50 years ago. But then why aren't we building bases on the Moon right now? Why haven't we returned to the Moon? If you'd like to know the answer to that question, watch this video.